Hello everyone to the last section of notes for AB Calculus. This is 6.4. This is volumes, but not by rotating, but by cross-section. And this is one of the more difficult things to see conceptually. So, instead of revolving these things, I'm going to take an area, a base, or something like that, just some area, and I'm going to build things up from it. That's kind of supposed to be a rectangle. It's coming up from a base. Or if you can imagine it, from the picture on the board, it's coming out towards you. Here's an example of a circular base with squares sitting on top of it. So that these are tiny squares because it's really short distance across the circle. As you get closer to the middle of the circle, you get bigger squares. And as you go further over here, you get smaller squares. So this is a circular base with a square cross-section. What if it was a circular base with a rectangular cross-section that is 5 tall? So now I have a circle on the bottom, and from that circle, I have a square, or a rectangle sticking up that's 5. And I have it everywhere. No matter where I go, I have the same rectangle. What shape would that make? What three-dimensional shape would that make? A can. Where the cross-section, the vertical section, or a cylinder, it's a rectangle. Why is this one not like this one? Why is this one sloped and this one isn't? Because this rectangle is always 5 inches tall, whereas this square gets bigger and smaller depending on how big the base is. This is a circle with a triangle as a cross-section. It's kind of hard to see. The real idea here, guys, is that you don't really need to know what these shapes look like. It helps, but you don't have to know what they look like. But you do need to know some basic geometry. Things like, and we'll talk about it in a second. Create the area of the base by using the area formulas we already know. Use dx for perpendicular to the x-axis and dy for perpendicular to the y-axis. So we're going to do the area. So remember that. Base is equal to the area, which means it's the integral of big minus small. The base is always the integral of big minus small. Then we determine what formula we need to find the height. That's basic geometry, and we'll talk about that in a second. Then we use the geometric formula with the base above to create an integral. Now what do I mean by geometric formulas? Well, let's talk about a square cross-section. Remember, the base is always on the bottom. But what would the area of a square look like? Well, here's a square and the base is right here. What about this? This would also be the same as the base because it's a square. So this would be base squared. It's not too hard. What about for a rectangle? And let's say a rectangle that is the height is 4 times the base. And I'm just making something up here. The height is 4 times the base. Well, here's my rectangle. Here's the base, and here's 4 times the base. So then what would my area be? It's the base times 4 times the base. And you can clean that up if you wanted to and say it's 4 times the base squared, but we don't need to. The one that all people have trouble with are semicircles. Well, think about what that would look like. Here's the base, and there's a semicircle. But what's the area of a semicircle? Area of a semicircle is 1/2 pi r squared. It's 1/2 the area of a circle, which is pi r squared. But look at this circle. What's the radius of this circle? It's not the base. It's only half the base. So the area of a semicircle is 1/2 pi, 1/2 the base, quantity squared. And you'll see what I mean with these next examples. Let's take a look at this. We're going to use the same graph and just different cross sections for these next three examples. Find the volume of a solid formed by taking squared cross sections perpendicular to the x-axis, that means dx, of y equals square root of x, y equals 2, and x equals 0. So I'm talking about this area right in here. First thing I should do is figure out these 2 points. That's 0, 0. What's that point? Well, I know that y is 2. So what x value would I put here if I want y to be 2? 4. Let's talk about the base. If I want it dx, that means I want it vertically. What is the furthest function from the x-axis? It's the line. What's the line? 2 minus the closest one, the smallest function. What's the closest function to the x-axis? Square root of x. So in all of these problems, my base is going to be 2 minus square root of x. And I'm going to form shapes coming out of the board towards the camera that are squares in this problem. So, I know that it's going to be a square, which means that it's going to be base squared. Let's set up the integral. Let's do the things we already know. I know it's got to be dx. I know it's got to go from 0 to 4. I know the base is 2 minus square root of x. But I want a square with this base. So the area of that square would be the base squared. Now from here, guys, I'm going to just tell you what the answer is. I'm assuming you can either A, do this by hand, or B, plug this into the calculator. Your answer is 8/3. The setup is the most problem. Once you have it set up, it's pretty easy from then on out. Okay, again, let's talk about it. I created the base by doing top minus bottom. I knew it had to be a square, so I did base squared. 0 to 4 are my bounds, dx because it's x-axis, and then I just integrated. Now the next problem is the same, except instead of doing squares, I'm doing semicircles. It's the same graph, so I'm not going to draw it again. The area of a semicircle is 1/2 pi r squared, but in this case it's 1/2 pi 1/2 the base squared. What was the base from the last problem? The base is 2 minus square root of x. So let's set this problem up. It's still going to be from 0 to 4. I'm going to use this formula, so it's 1/2 pi times 1/2 the base squared dx. Again, I'm going to plug this into my calculator. This one does not come out nice and pretty. This is 2.094. The only difference in these two problems is that instead of using a square base, I used a semicircle base. But I kept everything else the same just to make it easy. For the last problem, I'm going to keep the functions the same, but now I'm going to do rectangle cross sections with the height 3 times the base. So, for this rectangle, it's going to be base times 3 times the base times height. So it's still going to be 0 to 4. The base is still 2 minus square root of x. But now the height is 3 times 2 minus square root of x. The setup is the hardest part. Once you have it set up, you can plug it into the calculator. This one works out pretty easy. It's 8. There's a lot more practice that we're going to do in class for cross-section volume. There's always usually 1 or 2 cross-section volume problems on the AP test. There's usually a rotational volume and a cross-section problem on the short answer of the AP test. As always, guys, if you have any questions, come talk to me. This section is confusing, but with practice, it's actually pretty easy. Thanks.